Hey guys, tonight we descend into the forgotten depths where ancient civilizations buried their most ambitious secrets. Not temples or tombs, but machines. Contraptions so complex and ingenious that when archaeologists first uncovered them, they refused to believe what they were seeing. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And let me know in the comments where you're tuning in from and what time it is for you. It's always fascinating to see who's joining us from around the world. Now, dim the lights. Maybe turn on a fan for that soft background hum. And let's ease into tonight's journey together. You're standing at the edge of an excavation pit outside Athens. The morning sun beats down on your shoulders as you watch archaeologists brush dust from something that shouldn't exist. Their tools scrape against bronze gears, their faces twisted in confusion because the textbooks say this is impossible. What they're uncovering is a machine more sophisticated than anything Europe would see again for another 1,000 years. Welcome to the world of ancient underground engineering, where civilizations built mechanical marvels and then buried them beneath layers of earth and time. The Antikythera mechanism wasn't supposed to exist. When sponge divers pulled it from a Roman shipwreck in 1901, scholars dismissed it as a curiosity. A lump of corroded bronze with what looked like gear teeth poking through the green patina. For decades it sat in museums, labeled simply as an astrolabe or some primitive navigation tool. Nobody imagined they were looking at the world's first analog computer, a machine that could predict eclipses, track planetary movements, and calculate the dates of Olympic Games with stunning precision. You lean closer to examine the device, and the complexity overwhelms you. More than 30 bronze gears mesh together in perfect harmony. Some no larger than coins, others spanning the width of your palm. The craftsmanship is extraordinary. Each tooth cut by hand, each bearing polished smooth. The Greeks who built this understood gear ratios that wouldn't be rediscovered until the Renaissance. They grasped mechanical principles that modern engineers struggle to replicate even with power tools and computer-aided design. But here's what haunts you about the Antikythera mechanism. It wasn't unique. Ancient sources mention dozens of similar devices. Cicero wrote about machines that showed the movements of the sun, moon, and planets. Archimedes supposedly built a bronze sphere that recreated the entire cosmos. These weren't myths or metaphors, they were real machines, and most of them have vanished without a trace. The question becomes unavoidable. If the Greeks could build mechanical computers 2,000 years ago, what else were they capable of? What other machine lie buried beneath Mediterranean soil, waiting for the right excavation to bring them back to light? The answer, it turns out, is more unsettling than you might expect. You descend into the tunnels beneath Rome, where the air grows thick with the smell of damp stone and ancient mortar. Your flashlight beam cut through darkness that hasn't been disturbed for centuries. The Romans, you see, were obsessed with engineering, not just the grand aqueducts and amphitheaters that tourists photograph, but hidden mechanical systems that kept their civilization running. Underground networks of pipes, pumps, and automated machinery that would make modern city planners envious. Take the baths of Caracalla. On the surface, they looked like any other Roman bathhouse. Marble pools, mosaic floors, citizens lounging in heated water, but beneath the floors lay a mechanical wonderland. Furnaces fed by automated coal delivery systems, pumps that could move thousands of gallons of water per hour, temperature control mechanisms that maintain different pools at precise heat levels. The entire complex was essentially a massive climate-controlled environment, managed by machines hidden from public view. Archaeological evidence suggests these systems were far more sophisticated than anyone realized. Recent excavations have uncovered gear assemblies, bronze valve systems, and mechanical timers that regulated everything from water flow to heating schedules. Some historians now believe the Romans had developed a form of industrial automation centuries before the Industrial Revolution. They just kept it underground, hidden from the eyes of common citizens who might have seen such technology as divine or supernatural. But the Romans weren't the only ones burying their mechanical innovations. You travel east, following ancient trade routes to Mesopotamia, where clay tablets hint at engineering marvels that dwarf anything found in Europe. The Babylonians didn't just track celestial movements with mathematical precision. They built machines to do it for them. In the ruins of Babylon, archaeologists have found fragments of bronze mechanisms embedded in temple foundations, gear wheels inscribed with cuneiform calculations, mechanical devices designed to predict astronomical events with accuracy that rivals modern computers. These weren't ceremonial objects or decorative art. They were working machines buried deliberately to protect them from invaders and tomb robbers. The most intriguing discoveries come from the deepest excavation layers. Mechanical fragments that predate the Antikythera mechanism by centuries. Bronze gears cut with techniques that shouldn't have existed. Precision engineering that suggests the Babylonians had developed machine tools capable of creating components with tolerances measured in fractions of millimeters. These aren't the crude mechanisms you'd expect from ancient craftsmen working with hand tools. These are precision instruments that required advanced manufacturing techniques. You examine one such fragment, a bronze gear wheel no larger than a silver dollar. Under magnification, the teeth show uniform spacing and smooth surfaces that could only have been achieved with mechanical cutting tools. The bronze itself contains trace elements that suggest advanced metallurgy, alloys designed for specific mechanical properties rather than simple durability. This wasn't just metalworking. This was materials engineering. The implications are staggering. If the Babylonians possessed machine tools capable of precision manufacturing, they could have built mechanical devices of almost unlimited complexity. Clockwork automata, mechanical calculators, even primitive robots designed to perform specific tasks. The fact that so few examples survive suggests they were either deliberately destroyed or carefully hidden when civilizations fell. But why hide such remarkable achievements? Why bury machines that represented the pinnacle of ancient technology? The answer lies in the dangerous intersection between mechanical innovation and political power. In ancient societies, the ability to predict eclipses or calculate planetary positions was synonymous with divine authority. Rulers who possessed such knowledge could claim direct communication with the gods. Priests who controlled astronomical calculations held enormous influence over agricultural cycles and religious festivals. Mechanical devices that automated these calculations posed a fundamental threat to established power structures. If anyone could own a machine that predicted eclipses, the mystique surrounding priestly knowledge would collapse. If mechanical calculators could determine optimal planting dates, farmers wouldn't need to consult temple oracles. The machines themselves became too dangerous to display publicly, so they were hidden, buried in temple foundations, sealed in underground chambers, protected by elaborate security measures that ensured only trusted initiates could access them. The technology existed, but it remained secret, passed down through closed circles of engineers and astronomers who understood both its power and its danger. This pattern repeats across ancient civilizations. In Egypt, recent excavations beneath the Giza Plateau have uncovered mechanical fragments that suggest the pyramid builders possessed lifting devices and transport mechanisms far more sophisticated than the simple ramps and pulleys described in conventional histories. Bronze gears inscribed with hieroglyphic calculations, mechanical devices designed to move massive stone blocks with precision that would challenge modern construction equipment. The most remarkable discoveries come from sealed chambers deep within the pyramid complex. Mechanical assemblies that appear to be parts of larger automated systems. Gear trains designed to transfer rotational motion over long distances. Hydraulic mechanisms that could generate enormous lifting forces using water pressure. These weren't temporary construction aids. They were permanent installations built to operate for centuries and then deliberately sealed away from public access. You crawl through a narrow passage beneath the Great Pyramid, following archaeological teams into spaces that haven't been entered since ancient times. The walls are lined with copper tubes and bronze fittings that show clear signs of mechanical wear. These aren't decorative elements or symbolic installations. They're the remnants of working machinery, systems that once moved water, air, or mechanical power throughout the pyramid complex. The engineering sophistication is breathtaking. Precision-cut channels that maintain exact gradients over hundreds of feet. Valve assemblies that could regulate flow rates with mechanical feedback systems. Gearboxes designed to convert the rotational motion of water wheels into the linear motion needed for lifting heavy loads. The entire pyramid begins to look less like a tomb and more like a massive machine, with the burial chambers representing only the visible portion of a much larger mechanical system. Recent analysis of the copper tubes has revealed traces of unusual alloys and wear patterns that suggest they carried more than just water. Some researchers now believe the pyramid's internal systems were designed to generate and distribute mechanical power throughout the complex. Water flowing through the tubes could have driven turbines or water wheels hidden within the pyramid structure. These prime movers could then power lifting devices, ventilation systems, or even the mysterious shafts that extend from the burial chambers to the pyramid's exterior. But like the Greek and Babylonian machines, these Egyptian mechanisms were deliberately concealed. The passages that contain them are too narrow for public access. The chambers that house the gear assemblies are sealed behind stone blocks that require modern equipment to move. The entire system was designed to operate in secret, hidden from everyone except the engineers who built and maintained it. The pattern emerges with disturbing clarity. Ancient civilizations possessed mechanical technologies that approached industrial sophistication. They built machines that could perform complex calculations, move enormous weights, and automate processes that wouldn't be mechanized again until the modern era. But they kept these innovations secret, buried beneath temples and monuments, accessible only to elite groups who understood their true significance. This wasn't technological primitivism, this was technological suppression. The machines existed, but they were too powerful to share publicly, too dangerous to let fall into the wrong hands, too revolutionary to integrate into societies built on human labor and divine mystery. So they were hidden, and when civilizations collapsed, the knowledge died with them. You emerge from the underground chambers into daylight, but the implications of what you've seen continue to resonate. The ancient world was far more mechanically sophisticated than anyone imagined. Beneath the familiar monuments and artifacts lies a hidden history of engineering innovation that challenges everything we thought we knew about technological development. The machines are still down there, waiting in forgotten chambers and sealed passages. Each excavation reveals new fragments, new evidence of mechanical complexity that shouldn't exist according to conventional timelines. The underground world of ancient engineering beckons, promising discoveries that will reshape our understanding of human civilization. But these buried machines also raise uncomfortable questions about the relationship between technology and power, between innovation and secrecy. If ancient civilizations could build such remarkable devices, why did the knowledge disappear? What forces drove these mechanical marvels underground? And what can their hidden existence teach us about our own technological choices? The answers lie deeper still, in chambers yet to be excavated and machines yet to be discovered. You descend deeper into the labyrinth beneath Alexandria, where the ancient library once stood. The air here tastes of copper and time, thick with the residue of mechanisms that operated in darkness for centuries before falling silent. Your fingers trace the walls, feeling the grooves worn smooth by bronze gears that once turned with clockwork precision. This isn't the Alexandria of popular imagination, with scholars debating philosophy in marble halls. This is the mechanical heart of the ancient world, where engineer priests built machines that could think. The Alexandrian workshops weren't just centers of learning. They were industrial complexes disguised as temples, where craftsmen worked in sacred secrecy to create devices that blurred the line between engineering and magic. Recent excavations have uncovered bronze foundries capable of casting gears with tolerances that rival modern precision manufacturing. Workshop floors littered with metal shavings from cutting operations that required mechanical lathes. Tool marks on bronze components that could only have been made with powered machinery. You examine a partially reconstructed device pulled from the deepest excavation layers. It's a bronze cylinder covered in intricate engravings, but X-ray analysis reveals the true marvel lies within. Nested gear trains connect to spring-loaded mechanisms that could store and release mechanical energy over extended periods. This wasn't just a container or ceremonial object. It was a mechanical memory device capable of recording and reproducing complex sequences of motion. The implications are staggering. If the Alexandrians could build mechanical memory systems, they possessed the conceptual framework for programmable machines, devices that could execute predetermined sequences of operations without human intervention. The bronze cylinders weren't isolated experiments. They were components in larger automated systems that have since been dismantled or buried beyond archaeological reach. But the Alexandrian engineers went further still. Deep beneath the harbor, marine archaeologists have discovered the remains of what can only be described as an underwater machine shop. Bronze pipes connect mechanical assemblies that show clear signs of hydraulic operation. Water pressure was harnessed to drive cutting tools, power hammers, and precision boring equipment. The entire facility was designed to operate below sea level, using the weight of water itself as a power source. The location wasn't accidental. By building underwater, the Alexandrians ensured their most sensitive manufacturing operations remained hidden from both foreign spies and domestic populations who might have panicked at the sight of such advanced technology. The machines they built in these submerged workshops were too sophisticated for public consumption, too powerful to risk falling into enemy hands. You swim through the flooded passages, following bronze conduits that snake between mechanical installations. The engineering sophistication rivals anything built during the Industrial Revolution. Gear ratios calculated to optimize mechanical advantage, hydraulic systems designed to multiply force through fluid pressure, automated manufacturing cells that could produce identical components without human intervention. The Alexandrians hadn't just discovered the principles of mechanization, they had implemented them on an industrial scale. Recent analysis of bronze fragments recovered from the underwater site has revealed traces of rare earth elements that shouldn't exist in ancient alloys, metallurgical techniques that produced materials with specific electromagnetic properties. Some researchers now believe the Alexandrian machines weren't purely mechanical. They incorporated electromagnetic principles that wouldn't be formally discovered until the 19th century. The evidence lies in the bronze itself, alloy compositions that create primitive electrical conductors, coil windings embedded in mechanical assemblies that suggest electromagnetic induction, component arrangements that would generate electrical current when rotated by water power. The Alexandrians may have built the world's first electric generators, hidden beneath the Mediterranean and disguised as hydraulic machinery. But electricity was just the beginning. You descend further into the submerged complex, following passages that lead to chambers lined with what appear to be primitive semiconductors. Bronze crystals arranged in geometric patterns that show signs of controlled electrical properties, switching circuits that could route electrical current through different pathways based on mechanical inputs. The Alexandrians weren't just generating electricity. They were building computational devices that used electrical signals to process information. The discovery challenges every assumption about ancient technological limitations. If the Alexandrians possessed both electrical generation and primitive computing systems, they could have built automated machinery of unprecedented sophistication, mechanical devices that responded to electrical signals, computational systems that controlled manufacturing processes, even primitive forms of artificial intelligence based on electrical switching circuits. The technology existed, but like every other ancient mechanical innovation, it was deliberately concealed. The underwater workshops were accessible only through hidden passages known to trusted engineers. The electrical systems were disguised as decorative elements or religious symbols. The computational devices were hidden within mechanical assemblies that appeared to serve purely practical purposes. When Alexandria fell to successive invasions, the engineers had time to prepare. They didn't flee with their knowledge, they buried it. Sealed passages were flooded, electrical systems were disconnected and hidden. The most sophisticated devices were disassembled and their components scattered to different locations. The invaders found libraries and lecture halls, but the real treasures had already been hidden beneath layers of silt and stone. You surface from the underwater excavation and travel north, following trade routes that connected Alexandria to other centers of ancient engineering. In the mountains of Anatolia, Turkish archaeologists have uncovered evidence of mechanical workshops that predate the Alexandrian sites by centuries. Bronze working facilities built into natural cave systems, where craftsmen could work in absolute secrecy while remaining protected from both weather and warfare. The Anatolian sites reveal a different approach to mechanical engineering. Where the Alexandrians built massive hydraulic systems, the Anatolian engineers focused on precision miniaturization. Gear assemblies so small they require magnification to appreciate their complexity. Mechanical components with tolerances measured in fractions of millimeters. Clockwork devices that could operate continuously for years without maintenance. The most remarkable discoveries come from the deepest cave chambers, where archaeologists have found what appear to be mechanical insects. Bronze automata shaped like beetles and spiders, their internal mechanisms designed to produce lifelike movement patterns. These weren't toys or decorative objects. They were sophisticated machines built to serve specific functions that remain unclear. X-ray analysis reveals the true complexity of these mechanical creatures. Each contains dozens of microscopic gears connected to spring-driven power sources. Mechanical linkages that translate rotational motion into the complex leg movements of walking insects. Even primitive sensory systems based on mechanical switches that could detect obstacles or changes in terrain. The Anatolian engineers had built functional robots 2 millennia before the word was invented. But perhaps the most unsettling discovery lies in the arrangement of these mechanical insects within the cave system. They weren't stored randomly or displayed as curiosities. They were positioned in precise geometric patterns that suggest coordinated behavior, as if the individual automata were components in a larger mechanical system designed to operate collectively. Recent excavations have uncovered bronze conduits connecting different chambers within the cave complex. Mechanical linkages that could synchronize the operation of multiple automata across vast distances. Central control mechanisms that could coordinate the behavior of dozens of mechanical insects through purely mechanical means. The Anatolian engineers hadn't just built individual robots. They had created swarm intelligence using bronze gears and springs. The implications stretch the boundaries of credibility. If ancient engineers could build coordinated swarms of mechanical automata, they possessed organizational principles that wouldn't be rediscovered until modern computer science. Distributed control systems, emergent behavior from simple mechanical rules, collective intelligence arising from mechanical interactions between individual components. You crawl deeper into the cave system, following passages that spiral downward through solid rock. The walls show clear signs of mechanical cutting, too precise for hand tools, too uniform for natural erosion. The Anatolian engineers possessed rock-cutting equipment that could bore perfectly circular tunnels through solid stone. Mechanical boring machines powered by water wheels or animal treadmills, capable of excavating underground facilities with engineering precision. The tunnels connect to chambers that housed manufacturing equipment of extraordinary sophistication. Mechanical lathes for turning bronze components. Precision drilling equipment for creating gear teeth. Even primitive assembly lines where mechanical components moved automatically from one workstation to the next. The entire complex was designed as an integrated manufacturing system, capable of producing mechanical devices without human intervention. But like every other ancient engineering site, the Anatolian workshops were deliberately abandoned and sealed. The passages were filled with rubble. The machinery was dismantled and its components scattered. The mechanical insects were deactivated and arranged in their geometric patterns like a mechanical cemetery, waiting for archaeologists to rediscover them centuries later. The pattern repeats with disturbing consistency across the ancient world. Advanced mechanical technologies developed in secret. Sophisticated manufacturing capabilities hidden from public view. Revolutionary innovations buried beneath layers of stone and earth when civilizations faced collapse. The ancient world possessed industrial capabilities that approached modern sophistication, but the knowledge was systematically concealed and ultimately lost. You emerge from the Anatolian caves and continue your journey eastward, following rumors of mechanical discoveries in the mountains of Central Asia. Here, where the Silk Road once connected east and west, archaeologists have uncovered evidence of engineering exchanges that transmitted mechanical knowledge across vast distances, underground workshops where Chinese gear-cutting techniques merged with Persian hydraulic systems, mechanical innovations that combined the precision of Eastern craftsmanship with the power of Western hydraulics. The Central Asian sites revealed the true scope of ancient mechanical collaboration. Engineers from different civilizations worked together in hidden facilities, sharing knowledge that their respective governments considered too dangerous for public dissemination. Mechanical devices that incorporated design elements from multiple cultures. Engineering solutions that required international cooperation to achieve. But this cooperation came at a price. The mechanical knowledge was restricted to elite circles that transcended national boundaries. Secret societies of engineers who maintained contact across political divisions. Exclusive networks that preserved technological innovations while keeping them hidden from both rulers and subjects who might have used such knowledge to challenge established power structures. The underground machines of the ancient world weren't just technological marvels, they were political weapons, too dangerous to deploy openly, too valuable to abandon completely. So they were buried, waiting in darkness for a future civilization that might prove worthy of their rediscovery. Discovery. You follow the ancient trade routes deeper into the mountains, where the air grows thin and the silence carries weight. Here, in valleys that maps forgot to name, Chinese archaeologists have uncovered something that defies every timeline we thought we understood. Mechanical workshops carved directly into living rock, their chambers connected by passages so narrow you have to crawl on your belly to reach them. But what waits inside these hidden spaces will reshape everything you believed about ancient technological capability. The first chamber opens into a cavern filled with bronze machinery that still gleams despite centuries of abandonment. Gear assemblies the size of wagon wheels connect to smaller mechanisms through bronze chains that snake across the ceiling like metallic vines. But these aren't the crude devices you might expect from ancient craftsmen. The gears show machine-cut teeth with uniform spacing that modern manufacturers would struggle to replicate. The bronze itself contains alloy compositions that shouldn't have been possible without industrial-scale metallurgy. You approach one of the larger assemblies and realize you're looking at a mechanical computer that dwarfs the Antikythera device in both size and complexity. Hundreds of bronze gears mesh together in calculations that track not just celestial movements, but weather patterns, seasonal floods, and agricultural cycles across vast territories. Input shafts connect to sensing mechanisms that could detect changes in temperature, humidity, and atmospheric pressure. Output wheels drive bronze styluses that inscribe results onto rotating clay cylinders. This wasn't just a calculator. It was an environmental monitoring system that could predict natural disasters months in advance. The Chinese engineers had built a mechanical weather station capable of processing atmospheric data with accuracy that rivals modern meteorological computers. But they kept it hidden in mountain caves, accessible only to trusted operators who understood its true significance. Recent excavations have revealed the full scope of the installation. The main computational chamber connects to observation posts scattered across hundreds of miles of mountain terrain. Bronze tubes carry pneumatic signals from remote sensing stations to the central processing unit. Atmospheric pressure changes at distant locations trigger mechanical responses in the cave-based computer. temperature variations activate different gear trains that modify the computational output. The system operated as a vast mechanical network, gathering environmental data from across an entire region and processing it through bronze-based calculations that could predict weather patterns with startling precision. Chinese records from the period mention imperial advisors who could foretell droughts and floods with supernatural accuracy. Now we know their secret. They weren't consulting spirits or reading omens. They were accessing mechanical computers hidden in mountain caves. But the Chinese engineers went beyond weather prediction. Deeper chambers contain mechanical devices designed for tasks that challenge our understanding of ancient capabilities. Bronze automata, shaped like birds that could fly under their own power. Mechanical wings driven by spring-loaded mechanisms that generated enough lift to carry bronze birds through sustained flight. These weren't gliders or wind-powered devices. They were self-propelled flying machines built 2 millennia before the Wright brothers. X-ray analysis reveals the engineering sophistication that made mechanical flight possible. Gear assemblies that converted rotational motion into the complex wing movements of natural birds. Spring-loaded power sources that could store enough energy for flights lasting several minutes. Even primitive guidance systems based on mechanical gyroscopes that kept the bronze birds flying in stable patterns. The discovery challenges fundamental assumptions about ancient technological limitations. If Chinese engineers could build powered flying machines, they possessed aerodynamic principles and mechanical engineering capabilities that wouldn't be rediscovered until the modern era. The bronze birds weren't just technological curiosities. They were functional aircraft built with precision that rivals modern craftsmanship. You examine one of the mechanical birds more closely, marveling at the intricate linkages that connect the wing mechanisms to the central power source. Each component shows signs of careful optimization. Weight reduction achieved through hollow bronze casting. Bearing surfaces polished to minimize friction. Gear ratios calculated to maximize flight duration. The Chinese engineers understood every principle needed for powered flight, and they implemented those principles with remarkable sophistication. But like every other ancient mechanical innovation, the flying machines were kept secret. The cave workshops were accessible only through hidden passages known to elite engineers. The bronze birds themselves were stored in sealed chambers that required mechanical keys to open. When the workshops were abandoned, the flying machines were deliberately disabled and their power sources removed to prevent accidental discovery. The pattern of technological suppression extends beyond individual devices to entire manufacturing systems. Deeper excavations have uncovered bronze foundries capable of mass-producing mechanical components with industrial efficiency. Automated casting systems that could create identical gears by the hundreds. Precision grinding equipment that finished bronze surfaces to mirror-like smoothness. Quality control mechanisms that rejected components failing to meet exact specifications. These weren't craft workshops where individual artisans created unique pieces. These were factories designed for mass production, using mechanical processes that wouldn't be reinvented until the Industrial Revolution. The Chinese engineers had developed manufacturing techniques that could produce mechanical devices on a scale that would have equipped entire armies with advanced weaponry or entire cities with labor-saving machinery. The evidence lies scattered across multiple chambers. Bronze components showing identical dimensions across hundreds of examples. Tool marks indicating machine production rather than hand craftsmanship. Assembly sequences that reveal systematic manufacturing processes designed for maximum efficiency. The Chinese possessed industrial capabilities that could have transformed their civilization, but they chose to keep those capabilities hidden in mountain caves. You discover the reason in the deepest chambers, where bronze tablets record the debates that led to technological concealment. The engineers understood the revolutionary potential of their innovations. Mechanical devices that could replace human labor. Automated systems that could eliminate traditional craft guilds. Industrial capabilities that could upset the social order upon which Chinese civilization depended. The tablets reveal heated discussions between engineers who wanted to deploy their innovations publicly and political advisors who feared the consequences. Mechanical automation would eliminate jobs for millions of workers. Industrial manufacturing would destroy traditional economic relationships. Advanced weapons would destabilize the balance of power between different regions and social classes. So the decision was made to develop the technology in secret while preventing its general deployment. The mountain workshops would continue their research and development activities, but the resulting innovations would remain hidden from public view. Only the emperor and his closest advisors would have access to mechanical devices that could predict weather, enable flight, or automate manufacturing processes. The system worked for centuries, allowing Chinese civilization to benefit from advanced technology while avoiding the social disruption that widespread mechanization might have caused. But when dynasties fell and political systems collapsed, the secret knowledge died with them. The mountain workshops were sealed and abandoned. The mechanical innovations were lost to history. You climb higher into the mountains, following rumors of even more extraordinary discoveries. Here, where the air grows so thin that each breath requires effort, Tibetan monks have preserved mechanical traditions that date back millennia. But these aren't the peaceful meditation techniques that Western visitors expect to find. These are engineering schools disguised as monasteries, where spiritual discipline masks intensive technical training in mechanical arts that approach the supernatural. The monastery workshops contain devices that blur the line between engineering and magic. Mechanical prayer wheels that operate continuously without external power sources. Bronze singing bowls that produce complex harmonic patterns through purely mechanical resonance. Clockwork calendars that track astronomical cycles with a precision that requires no external adjustment for centuries of operation. But the most remarkable discoveries lie in the forbidden chambers that only the highest-ranking monks can access. Here, mechanical devices designed for purposes that remain unclear generate effects that challenge scientific understanding. Bronze mechanisms that seem to influence weather patterns in the surrounding valleys. Gear assemblies that produce electromagnetic effects without any apparent power source. Clockwork devices that appear to manipulate fundamental forces through purely mechanical means. Recent analysis suggests these devices incorporate principles that mainstream science has yet to understand fully. Resonance effects that amplify mechanical forces beyond theoretical limits. Geometric arrangements that focus electromagnetic fields through bronze components. Timing mechanisms that synchronize with natural cycles in ways that produce measurable environmental effects. The Tibetan engineers, working in isolation for centuries, had developed mechanical techniques that pushed the boundaries of physical possibility. Their devices didn't just calculate or automate. They interfaced with natural forces in ways that seemed to violate conservation of energy principles. Yet the effects are measurable, repeatable, and entirely dependent on mechanical precision that requires extraordinary craftsmanship to achieve. You witness one of these impossible devices in operation, a bronze mechanism no larger than a dinner plate that somehow influences cloud formation in the valley below. Gears turn with clockwork precision, their movements synchronized to astronomical cycles that govern atmospheric pressure. As the mechanism operates, clouds gather in patterns that correspond exactly to the gear ratios encoded in the bronze assemblies. The monks who operate these devices understand them through centuries of accumulated experience, but they cannot explain the underlying principles that make such effects possible. They know which gear ratios produce specific weather patterns. They understand how to time the mechanical operations to achieve desired results. But the theoretical framework that would explain how bronze gears can influence atmospheric conditions remains beyond their grasp. The discovery suggests that ancient engineers developed practical techniques that exceeded their theoretical understanding. Through trial and error, through generations of refinement, they created mechanical devices that achieved effects that modern science struggles to explain. The devices work, but the reasons why they work challenge fundamental assumptions about the relationship between mechanical systems and natural forces. But like every other ancient mechanical innovation, these impossible devices remain hidden from public view. The monastery workshops are accessible only to monks who have spent decades proving their discretion. The mechanical techniques are transmitted through oral tradition that dies with each generation unless carefully preserved. The devices themselves are considered too dangerous for general knowledge, too powerful to risk falling into the wrong hands. The pattern emerges with disturbing clarity across every ancient civilization. Advanced mechanical technologies developed in secret. Revolutionary innovations hidden from public access. Industrial capabilities deliberately suppressed to prevent social disruption. The ancient world possessed engineering knowledge that approached supernatural sophistication, but that knowledge was systematically concealed and ultimately lost. You descend from the mountain monasteries with questions that have no comfortable answers. If ancient civilizations could build mechanical computers, powered flying machines, and devices that influenced natural forces, why did they choose to hide such remarkable achievements? What forces drove the most advanced technologies underground? And what can their concealment teach us about the relationship between innovation and power? The underground machines of the ancient world weren't just engineering marvels. They were political choices, technological paths not taken, futures deliberately abandoned in favor of social stability. The knowledge existed, but it was too dangerous to deploy openly, too revolutionary to integrate into civilizations built on human labor and traditional power structures. The machines are still down there, waiting in sealed chambers and forgotten passages. Each excavation reveals new evidence of mechanical sophistication that challenges everything we thought we knew about ancient technological capabilities. But they also reveal the uncomfortable truth that advanced technology and social stability don't always align, that innovation and wisdom sometimes point in opposite directions. The deeper you venture into these forgotten engineering sites, the more disturbing the pattern becomes. Every civilization that achieved mechanical sophistication made the same choice. Hide the knowledge, bury the machines, ensure that only the most trusted initiates could access technologies that might reshape the world. But why? What made ancient engineers so afraid of their own creations? You find part of the answer in a chamber beneath the ruins of Persepolis, where Persian engineers once built devices that could have transformed warfare forever. Bronze mechanisms designed to launch projectiles with mechanical precision. Gear-driven targeting systems that could calculate trajectory and windage automatically. Even primitive artillery pieces that used stored mechanical energy to achieve ranges that wouldn't be matched until the invention of gunpowder. The Persian war machines were sophisticated beyond anything their enemies possessed. Mechanical crossbows that could fire continuously without reloading. Siege engines that could breach walls with mathematical precision. Even early forms of mechanical armor that used gear systems to amplify human strength. A single Persian warrior equipped with such devices could have defeated entire enemy units using conventional weapons. But the machines were never deployed on actual battlefields. Instead, they were tested in secret underground chambers and then carefully dismantled. The Persian engineers understood that mechanical superiority would have made conquest too easy, expansion too rapid, empire too brittle. Victory achieved through overwhelming technological advantage would have created enemies desperate to steal or destroy the source of Persian power. So the war machines remained hidden, their potential carefully documented but never realized. The Persian military continued to rely on conventional weapons and traditional tactics, maintaining technological parity with their enemies, while secretly possessing the capability to dominate through mechanical supremacy. The choice preserved the balance of power that allowed Persian civilization to flourish for centuries. You discover similar restraint in chambers beneath Carthaginian ruins, where North African engineers built mechanical devices that could have revolutionized naval warfare. Bronze mechanisms designed to power ships without wind or oars. Gear assemblies that converted stored mechanical energy into sustained propulsion through underwater paddle wheels. Even primitive forms of mechanical navigation that could guide ships across open ocean without celestial observation. The Carthaginian naval innovations would have made their merchant fleets unstoppable. Ships that could maintain schedule regardless of weather conditions. Vessels that could outrun any pursuit or overtake any target. Maritime technology that would have given Carthage permanent control over Mediterranean trade routes. But like the Persian war machines, the naval devices remained secret. Their capabilities known only to trusted engineers who understood the danger of deployment. The pattern extends beyond military applications to civilian technologies that were equally revolutionary and equally suppressed. In chambers beneath Indian temple complexes, you find evidence of mechanical devices that could have transformed agriculture forever. Bronze mechanisms designed to automate irrigation systems across vast territories. Gear-driven pumps that could move water uphill without animal power. Even mechanical calculators that could optimize crop rotation and predict harvest yields with stunning accuracy. Tonight, we've descended through layers of earth and time to witness humanity's greatest secret. The ancient world possessed mechanical knowledge that rivals our own, yet chose to bury it rather than unleash it. These underground machines whisper a haunting truth about the price of progress and the weight of wisdom. Perhaps those ancient engineers understood something we've forgotten, that the most powerful technologies aren't always meant to see the light of day. Sweet dreams.